Hello friends, in this video we are going to study set operations. So here we need first to identify how many operations we can perform on a set. There are mainly 5 operations on a set we can perform. First is complement of set A, second is complement of set A, second is union of set, intersection of set, difference of set, and symmetric difference of set. Okay, so start first is complement of set. So what is by complement of a set? Any particular set means a set, suppose. Okay, so first we study what is the definition of complement of set. The complement of the set is the set of those elements of the universal set U but which are not in A. Suppose we want to find out the complement of a set A. Okay, so that times we consider all the elements of U but not in A. That means the set is a complement, which is the complement set which is denoted by this is a complement or this symbol. Okay, we can use these symbols a bar or a dash. This symbol which are used for to denote the to express the complement of a particular set. Okay, so next, for example, how to find out the complement of a particular set. So for example, here U is a universal set. Suppose universal set contains total 9 numbers: 1 2 3 4 5 6 7 8 9. Okay, so here a set universal set contains U equals to 1 to 9, 1 2. So now here universal set U contains U equals to 1 2 3 4 5 6 7 8 9 curly braces. Okay, so universal set contain total 9 numbers and A is given. A equals to universal set is also given and A is also given 1 1 2 7 and 9. Okay, and now here is asked for to find out the A complement equals to. Okay, this is the notation for a complement. So A complement, A bar. Okay, so all the complement set which contains all the elements of U but not in A. Okay, but here one is here. Okay, there is no need to consider the one number to continue one complement. A complement 1 2 3 आएगा नहीं, so 3. Next 4 elements which are not contained in A, so that's why 4 is also member of a complement. Next 5 is also member of A complement. 6, yeah, okay. Next number 7 which are in A set, so there is no need to consider. Next 8 which are not in 8 in A set. 9, so this is the A complement. Okay, so A complement means all the elements of U but not in A. That means A complement. Okay, are you getting? Next, does A bar can be written as? A bar written as means how, which types of elements the A set consider or contains in A complement. A complement, A complement which contains the element X such that X belongs to U. X belongs to U and X not belongs to A. A complement which contains the element X such that X belongs to U, universal set, but not in X not belongs to A. So this is a complement. This is the proper syntax of a complement. Okay. And next is more important things is, if you have a null set, empty set, if you have a null set, so that times the complement of a null set equals to universal set, because null set contains 0 elements. So that means null set complement equals to all the elements of universal set, because in null set contains 0 elements, and universal set complement is equals to 5, because universal set means it is a superset which contains all the elements. Okay, and complement of universal set means it is a null. Okay, all the elements, complement means all the elements of universal set but not in particular set. But here in this example, just find out the universal complement means, because universal set contains all the elements, it is a superset, so it is always the complement of universal set is always 5. Okay, so second operation is, next goes to second operation, union of a set. Union of set means, so first we understand the what is the proper definition of a union of set. The union of two set A and B is the set of all those elements which are either in A set or in B set or in both set. Okay, so union set which contains all the elements of A, all the elements of B, or all the both the elements which are in both set. Okay, so one thing is that in union set, if the two sets, suppose A set and B set, there are two sets, A set and B set, we have considered two sets. Okay, and both set contains the one or more elements common, so that time we need to consider one time only. If the numbers repeatedly occurs in both sets, same numbers occurs in both sets, that time we consider those elements only at consider only one time in a union B set. Okay, for example, suppose if A equals to, suppose A set contains 2, 5, 9 and 15. Okay, and second B set which contains 1, 2, 4, 5, 6. This is complete. Okay, so how to find out the union of A union B? So A union B equals to all the elements of A, the elements which are in A or in B or in both. Okay, so here 2 occurs starting from lowest number. Okay, so 1 occur in B but not in A, consider one time. Okay, second 2 occurs in both set, A set and B set also, consider one time only. Okay, next 3 not present in any set. Next 4 elements in B occur one time. 5 occur in both set but we consider only one time. Next 6 occur in B set, 7, 7 is not present in both set. 8 not present in both set. Okay, and here next number is 9, 9 which is present in A set, consider one time, and last number is 15. Okay, so this is a union B in set. Okay, so first here we count 1 2 3 4 5 6 7 elements, and here 1 2 3 4 5 6 7 elements. Okay, so A union B we can find by this way. Okay, are you getting? So if you have any doubts, you can ask me on a WhatsApp group. Okay, you can directly message. And one thing is that when you view this channels or this video, so that times you write down your roll number, your name in the comment box. Okay, so this is the attendance of you. So this is the A union B. Next, there are some important notes is A union A is always A. For example, suppose A contains 1 2 elements. Okay, A contains A union A equals to A. For example, A equals to 1 2 elements, and here we need to find out the A union A means 1 2 union 1 2. Okay, so A union E equals to 1 1. Here both set contains 1 because A union E same set union with same set. Okay, so 1 2, and this 1 2 which both elements belongs to A set. That means A union A is always A. Okay, next second A union phi. A union phi always A. Suppose A equals to 1 2, and second set phi means, suppose we are consider B, and this is a phi means null set. Okay, so how to find out the A union B means A union phi. Okay, equals to all the elements of A and all the elements of B. Union means all the elements of A and all the elements of B, and common element consider only one time. So all the elements of A and B contains empty null set. So means this is the answer for a union phi, means this is the 1 and 2. These elements belongs to A set. So A union phi equals to A. Okay, next A union B. So here condition is occurs A union B. Suppose we find out the here A union B if, so A union B, this answer which depends on a condition, which type of condition. If A union B equals to A, if B is a subset of A. If B is a subset of A, so that time A union B equals to A. So how it is possible? So for example, A equals to 1 2 3, and B equals to suppose 1 only 1. So B, because B is subset of A. Okay, so all the elements of B which are belongs to A means B is a subset of A. So that time we find here A union B equals to what is the answer? A union B, 1 1 common, consider one time. Next 2 but not here, consider one time, and next 3 but not in B set, So that time consider 1 2 3, and this 1 2 3 we obtain the 1 2 3, and these are the members of A. So that's why A union B equals to A if B is a subset of A. Okay, so next point is A union B if A union B equals to B. If condition is A is a subset of B. A is a subset of B. Okay, here mention. So here's for example A equals to 1 and B set which contains 1 1 B set contains 1 comma 2. Okay, so here A is a subset of B because all the elements of A which are belongs to B, and A set contains only one element 1 and which is belongs to B set. That means A is a subset of B. So that times we here we find the A union B for both set A union B 1 in both set one time, and 2 in only B, what's it 2. Okay, so this is, and 1 and 2 those elements which are belongs to B set. So that means A union B equals to B if A is a subset of a B. Are you getting? Next example, next point is A union U. U means universal set. Okay, A union U equals to universal set, because suppose universal set contains 1 2 3 4. Suppose universal set contains 4 elements and A set contains 1 2 elements. So that times A union universal set equals to 1 in both set, 2 in both sets, consider one time, 3 in only universal set 3, and 4 which is in only universal set. Okay, so all the elements you have considered, and this is a all 1 2 3 all these are members of a universal set, means A union U universal set equals to universal set. And next point is A union A complement. A union A complement. A union A complement equals to universal set. So here first universal set is equals to suppose 1 2 3 4. Okay, and A equals to suppose A contains only one elements, and how to find out the A complement equals to all the elements of U but not in A, one which is contained in A sets. So that times there is no need to consider the one elements in A complement. Second elements, only one element set A contains and all other elements of U 2 3 4. So this is a complement. Okay, and now to find out the A union A complement equals to 1, considering A set 1, next to A complement set 3 4. Okay, so these are 1 2 3 4 all these are members of universal set U. So that times A union A complement is always universal set. Okay, this is a union operations which are performed on a set. Next, intersection of the third point is intersection of two sets. So what is by intersection of two sets? The intersection of the sets A and B in the set of all those elements which are both sets which are in both set A and B, it is denoted by this symbol intersection A intersection B. Okay, intersection means if the elements which are contains in both sets A and B, so that time we consider those elements and all other elements are ignore or discard. A intersection B. This is a notation for to denote the intersection of two sets. Okay, so the syntax for the intersection A intersection B equals to, which contains the x elements such that x belongs to A and x belongs to B. If these elements which are in both sets, so that time we consider it is a member of A intersection B. Okay, for example, A contains A equals to A set 1, 2, 3, 4. Okay, and B set equals to 2, 4. Okay, so here we need to, here we find the A intersection B equals to, in curly braces, just to find out the common elements in both set. 1, but 1 is not present in B set. Second element 2, which are present in A and which are also present in B, so common elements 2 consider. Next, A set, third element 3, which are present in A set, and 3 which are absent in A set, B set, so that's why there is no need to consider the 3 elements in A intersection B. Fourth, next element 4 which are in A set, and 4 number which are also member of a B set, so we consider the 4. This is a intersection B, means common elements we considered in A intersection B. Okay, so next thing is that, so there are some important points in A intersection B. A intersection B, A intersection A equals to A is always A, because the suppose follows A contains 1 and 2 elements. Okay, 1 and 2, there are 2 elements set, means A intersection A equals to 1 comma 2 intersection 1 comma 2. Okay, so intersection, the A intersection A equals to, in braces 1 1 1, 2 2 present 2, so this is the answer of A intersection A, and this is a, so all the elements of A, so that's why A intersection A is always A. Okay, second point is A intersection phi. A intersection phi always phi, obviously, because we consider common elements in both sets. Okay, so suppose A set contains 1 2 elements, and in a particular set is a null set, second set is null set, so answer of A intersection phi equals to, so here 2 elements, but one is present in A set but one is not present in null set, so ignore, discard the elements. Second element 2 which are present in A set but which are not present in null set, to discard, so this is a empty set, null set, so means the answer of A intersection phi is always phi, null set. Okay, second thing is, next point is A intersection B. A intersection B equals to B. If, here two conditions occur, if B is a subset of A, if B is a subset of A, suppose for example A set which contains 1 2 3 and B set which contains 1 only. Okay, so all the elements of A which are, all the elements of B which are belongs to, which are also member of A. Okay, so that means B is a subset of A. So next conditions here, to find out the A intersection B equals to, A intersection B equals to common elements in both sets, 1 which is a common elements in both sets. Okay, only 1 element considered in A intersection B, and this is a member of a B, this is a set A, this is a set of B, so that's why A intersection is always, A intersection B equals to B if B is a subset of A. Okay. Next, second point here, if A intersection B equals to A if if A is a subset of B. For example, A which contains one element and B which contains 2 elements. Okay, B set contains 2 elements, and here A set contains one element 1. Okay, and this elements also belongs to B. Okay, so all the elements of A set which are also belongs to B means A is a subset of B. So next, to find out the A intersection B equals to common elements in both set is 1. Okay, so this is A and this set is A set. That's why A intersection B is equals to A if A is a subset of B. Okay, are you getting? Next thing is A intersection universal set equals to A. Okay, suppose for example U equals to 1 2 3 4. These are the 4 elements in universal set, and A set which contains 1 and 2 elements. Okay, so A intersection universal set equals to just A intersection U universal set which contains the common elements of in A set and B set. Okay, 1 1 which are present in both sets, so considering A intersection B set. Second, 2 2 both are present in both set, so consider in intersection set. Next 3 which are in universal set but not in A set. 4 which are in U set but not in A set. That means the A intersection U is only 2 members. Consider only 2 members, 1 2, and which are the A intersection A comma 1 comma 2 equals to A. So both elements are present in A set, so A intersection U is always A. Next point, A intersection A complement is equals to 5. Okay, so now here for example universal set U which contains 1 2 3 4 suppose, and A set which contains 1 2, and here we need to first find out the A complement, because here U set is given, A set is given. Okay, so A complement, we need to find out the A complement. How to find out the A complement? All the elements of universal set but not in A, that means it is a complement set. Okay, 1 is present here, 2 is present there, next 1 present, 2 3 4, all the elements of universal set but not in A. 1 and 2 present in A set, and other elements 3 and 4 is not present in A set, that is a member of A complement. Okay, so next, to find out the A intersection A complement equals to, okay, 1 common elements, 1 present in A but not in present A complement, 2 which are present in A set but not in A complement. Next, complement A, 3 elements which are present in A complement but not in present A. That means the common elements not in A and A complements totally different. This is empty set or this is null set. 5 means A intersection A complement is always 5, null. Okay, next example is